Welcome to IoT Real Talk. No fluff, no filler, just real pros talking about real programs, real challenges, and real results. With more than 4,000 exhibitors and 148,000 attendees, the 2026 Consumer Electronics Show, also known as CES, again proved why it is the world's biggest technology event for first looks at what's next. Aeris' own founder and chief evangelist, Syed Zaeem Hosain, Z for short, he was on the ground in Las Vegas and joins us now on IoT Real Talk with his takeaways from the show and what they mean for connected tech. We will unpack why software-defined vehicles are moving from roadmap to reality, where edge AI is delivering value and where it's still smoke and mirrors, and how RedCap, Wi-Fi 8, and satellite are changing the economics of IoT at scale. Hi, everyone. Happy New Year. I'm your co-host, Susanna Song. John is on assignment. Well, this is the first episode of the new year. We had 9 episodes last year. That is since June of last year. So we had 9 in 6 months. We are doubling down, and we want to double that number for this coming year. So thanks to everyone who's joined us for the first 9, and hope you will continue with us on this journey. And what a great way to start with Aeris' co-founder, Z. Thanks for joining us, Z.
Thank you very much, Susanna. Wonderful to be here.
Z, before we jump into CES, I want to ask you about the recent announcement Aeris made around surpassing 100 million connected devices. I mean, you started the company 30 years ago with your co-founder. That is quite an achievement. What are your thoughts?
Oh, absolutely spectacular. I will tell you that is one of the most exciting news that I have heard this year, that we have reached that tremendous milestone. It started on my dining table, the whole technology development effort, the deployment, the network design, you name it. And we didn't have offices for the first year or 2, and we got going, and it was kind of cool. Our first customer was in the business alarm and residential alarm monitoring systems. I remember the first unit going onto our network, first commercial unit going onto our network in May or June of 1998. And we've come a long way since then. It's absolutely fantastic.
We sure have. It's great to be with you at Aeris and on this journey. Alrighty, let's get your thoughts on CES. This isn't your first rodeo.
No. I've been, and, there are times when I wish I hadn't gone, to be honest with you, because it can be a real madhouse. It is just amazingly crowded. The lines to get in the first few days, it's really tough. You have to wait almost an hour and a half to just get into the door. And nowadays, ever since the security has become much more paramount, if you happen to have a backpack on you, you got to be careful how you get in. What I saw was the continuous expansion, the IoT space, which, by the way, has a little interesting connection to Aeris. It's called the IoT Zone. It's in one corner of one of the buildings. We actually started that years ago, before the event was called. It was at a different venue, called the CTIA Wireless Show, and it was called M2M Zone. Aeris started it, and then we handed it off because we had competitors there, frankly, who wanted to have booths in the place. And it's developed over the years. It's now called the IoT Zone. So IoT is big. It's finally come of age. The evangelist portion of me kind of sort of says that we no longer have to talk about IoT as being evangelists, but security in IoT is now the next thing that people are starting to get onto.
Yeah, there are a
ahead.
ton of shiny objects at this show,
Yep.
but let's focus in on connected tech and what's ahead, starting with connected cars.
Sure.
An earlier episode, I should say, Raj Kanai joined us on the pod and kind of gave us the first forte of SDV. Software-defined vehicles have been talked about for years. So what did you see at CES that made it feel more real this time?
2 things, one of which was actual formal announcements by chip manufacturers that they're coming out with chipsets that have built-in AI and processor capacity and capability to be able to do this kind of stuff. So, for example, both NXP and Qualcomm, one of the 2 leading manufacturers in the semiconductor area for making product for cars, announced product. NXP announced a product that was going to allow AI to be implemented inside the vehicle. And Qualcomm and the Volkswagen Group, which happens to be one of our customers, by the way, announced that they have selected the Qualcomm Snapdragon processor for use in their next-gen SDV vehicles. I believe they said in 2027, they're going to actually have the first implementations come into play. And I'm not sure that's commercial release or testing, but certainly that's pretty aggressive and pretty quick. I'm sure the agreement has been in works for a while. Software-defined vehicles, Raj, I'm sure, has given you an explanation of exactly what that entails. A lot of processor power is needed, and you need to have these very powerful engines. And I don't mean automotive engines, I mean cellular and processor engines inside the vehicle to be able to achieve the kind of features that a software-defined vehicle can provide to you. The fact that Qualcomm became one of the leading players in the chip industry that Volkswagen Group has accepted as being their next generation platform is fantastic. Mercedes also did an announcement with another organization to not only the SDV, but just sort of expand what they call the digital platform inside the car. That essentially is the same basic concept. They just don't call it SDV, as I recall. But that's right there. They're expanding the capacity and capabilities within the vehicles to be able to do the kind of things that both SDV is going to take advantage of, as well as AI inside the cars.
From your perspective, Z, what changes when vehicles become software platforms instead of just connected products?
Right. I mean, if you look at the fact that connected product is really the assumption there that people make is that the data is going to go off the vehicle using a connectivity platform like cellular or satellite in certain cases. And that is data that is being sent off the car. What's happening inside the vehicle is that over the years, you're starting to see a large number of functions that used to be traditionally mechanical functions of some sort have been replaced by electrical functions of some sort. Very commonplace functionality, for example, is a steering wheel. In the early days, it was a mechanical connection from the wheel that the driver held to the wheels of the car itself. And later on, it became electronic. So you had a sensor that the steering wheel would use, and that would actually change motors inside the car. It is going beyond that. You're now starting to see these applications where you can measure all kinds of functions within the car that weren't traditional automotive parts. Like, for example, brake pad thickness. You had to actually take it into a dealer or a brake shop to be able to measure the thickness of your brake pads for safety. Nowadays, they have sensors that actually figured that all out. Early implementations were tire pressure monitoring. In fact, the NHTSA in the United States has required that you have to measure tire pressure and let the driver know if it's gotten too low, because that is a source of accidents and safety problems that can occur. So over time, you're starting to see more and more functions being replaced, not with mechanical or electrical chips or things like that, but going into things that you can update, things that you can fix on the fly, things that you can change, not just the guidance or the map systems that modern cars tend to have nowadays, but above and beyond that. Functionality of the engine management system, for example, is all in software. So if you define that in software, you can make changes to it. You can fix problems without having to have the owner come into a dealership. That is just absolutely phenomenal. In fact, I happen to have an electric vehicle that I can tell you in the 7 years that I've owned the car, I've only been into the dealership once. That's they've given me updates over the air. OTA, over the air updates, is requirement for connected anything, let alone connected cars. And that's sort of the next big wave that we orchestrate. Other people are actually relying on that to be able to fix things. Security is a big deal, by the way. If you have a problem that you need to fix in a connected device of any kind, let alone a connected car, you have to be able to do it in a very rapid way, because some of the new regulations that are coming along say that you have to respond and fix a problem within 24 hours. Well, just scheduling an owner of a car to come into a dealership in that time frame would be impossible. If you can do it over the air, you can fix the problem, take care of a security issue or some kind of a breach that has occurred. That is just phenomenal. So all kinds of areas are being converted softly into software controls that then can be repaired over the air, or possibly with some kind of a download that the owner does in their home. If it's a personal automobile that they do in their home using their Wi-Fi connected internet access, etc. Great stuff.
Yeah, I want to hone in on, though, when you said, with SDV now you can change things on the fly. You brought up security because when you think of it from the bad actor's perspective, their side of things, on the offense attacking, they could also change things on the fly. They can tweak and change. What are you? I'm sure you heard security brought up quite a bit at CES. You were also on a panel. What are your thoughts around security, SDV, and cellular connected things?
It's the next big target for the attackers. Absolutely. And the reason for that is very simple. Even though you're starting to see all these smart devices, connected cars and smart home systems, etc., ultimately they have a limited capability. It still doesn't have the human intelligence necessary to deal with I've got a problem. Maybe there's something I need to take care of. Software systems in general inside these connected devices are under attack. They're going to continue to be under attack. And if you haven't had these secure by design mindsets to begin with, you're going to leave yourself vulnerable to these kinds of attacks. And one of the mechanisms for repair is over-the-air updates. So it's necessary. So security is a big deal. And I'm sure you'll remember there was a large discussion of a car that was taken over as a demonstration of what could happen, almost 10 years ago at this point, where somebody remotely took over the vehicle and drove the car and did, changed the braking performance and literally drove the car into a ditch, all under a test condition, so the driver knew what was happening. But that's scary. Now, in a scenario where you can have that occur, you need to be able to repair that damage. And so security was a big push in a lot of areas, particularly when you have something as powerful as the next generation processors that are going into all these vehicles, because they are subject to problems. I think NXP and I forget exactly which other company it was there, announced a relationship with a company called QNX, which has been at the forefront of real-time operating systems for connected systems of various kinds. And NXP and QNX announced a relationship that they would provide that capability. I forget the car manufacturer's name, but it was a smaller car manufacturer that is going to implement that system as a whole. And security is a key aspect of it. Security by design, security by default, so it's enabled. And people are demanding it. And so there's a new phrase called security by demand, which I think is a very powerful concept, which is that people want it. So they're going to come to the car manufacturers and the connected device folks and say, is your device secure? Is it meeting the requirements and regulations that are coming into play? And if you can't prove that, that's a big deal.
What was discussed on your panel that you
very
presented
good.
for?
Sorry, I didn't mean to interrupt you there, but really the big topic of the day was people are looking at security. Is it a selling point for IoT? And the answer, the consensus in the panelists was yes, absolutely. Particularly in light of the regulatory environment. If you look at what's happening over in Europe, the Cyber Resilience Act, where you have to not only prove that your devices are secure, but you have to almost guarantee it because you're going to get massive fines if you don't. Aeris has actually been participating in a project called the IMC GCF Task Force on Cellular and Other IoT Security Systems for certification. All of these entities who are coming up with the regulations are not quite at the point of saying, how do you prove that you're indeed secure? And so this task force, the Global Certification Forum, the GCF and the IMC started this project a year and a half ago. And I think it's a very valuable project from the perspective that if you need to prove that you're secure to a regulator, this is going to be the approach that we take. So we're going to work on standards with them. I led the technical track. We proved the feasibility that we could do. And so the panel session was actually describing that it is indeed a capability and feature that people are sitting up and taking notice of. And so secure devices in the connected IoT space absolutely got to do it, whether it's cars or smart devices in the home, a fixed wireless access product that has the smarts necessary that they can do their functions, but could be taken over. And so you got to prove that they work and securely.
Let's switch gears. No doubt AI was everywhere at CES, but let's drill down to AI applications at the edge, or some would call AIoT. What's new? Where do you see edge AI actually delivering value today?
The biggest win that comes in is twofold. One of which is that you need to be able to respond to things rapidly. You don't want to wait for the data to be sent to a remote server, be processed, along with other data that's being gathered along the same lines for that same application or maybe similar applications, and then feed back the action. So in some cases, the localization of behavior, localization of performance is going to be absolutely mandatory. In the autonomous car space, for example, if you are driving along and in a city environment and a person steps in front of your car, you don't have time to send the data back to a server to say, what should I do? You need processing right there. So edge processing has been at the forefront of many high-end applications, if you will. And now the ability for AI to be incorporated in the embedded controllers that go into these systems to take advantage of the fact that you have the data. Let's make the response to the issue occur right there locally so that you don't have to worry about a long-range performance problem take place. That's number one. Number two is that it minimizes the cost, for example. If you're sending data and you're sending a lot of data, video data, for example, from a vehicle or from an application, a home alarm system application, you may be using megabytes and gigabytes if you're not careful, and you can reduce your cost by processing all of that data locally with under a careful control. And you need to make sure that the functionality is being overseen either by a human being or perhaps by a centralized system that can provide you the information necessary for that edge processing to occur properly and safely. So that's a big deal. Now, how far along is it? Still in the works, in the early works. There's a session and a paper that I read about. I didn't actually attend that, where someone was talking about low power devices. You've seen this explosion of sensors, and the problem is that the sensors aren't smart enough to be able to do AI type processing. But now you've seen these companies coming out with chips that can be enabled for doing that kind of edge AI processing combination, so that they're indeed more useful than just simplistic data gathering sensors of some kind. That's going to revolutionize, I would say, the explosive growth of AI in the edge environment, not just for industrial, but potentially consumer applications as well.
So what you're saying, there's still more, AIoT is still more promise than reality.
Yes, I would agree with that. I think it's still maybe 1 to 4 years away based on the chipsets just coming out that get incorporated into the products that are going to be using them.
How should product teams think about deciding when AI belongs at the edge versus in the cloud?
Darn good question. I guess it was a question of how much data they're trying to process and whether or not the information that information is being processed with the appropriate level of lack of hallucination, lack of errors, such that you can indeed make judgments. I'm very both bullish and bearish about the concept of AI being used for this purpose, because if you look at the amount of data, we're talking about billions of messages that we're transporting, let alone all the other companies that are doing the same thing. AI is essential. Machine learning and all of that analytics is essential, because there's no way that we can have enough humans overseeing the data. So it is important to start doing all of this stuff. Now, whether you do it in the device or the cloud, those two functions will depend, I think, on what you're trying to achieve. In a medical device, for example, I would be very careful about applying AI techniques to limit the data or to take action somewhere, because you might harm a human being. On the other hand, if it's a home heating system that you're gathering data on and you want to automatically adjust the temperature in certain rooms, why not, right? Those are the kind of things that I think AI, both AI as well as the ability of the smart processors that are out there that are being deployed today. I just saw a flyer recently for a new product where they have built-in smart sensors into the vents for a home. You can install these special sensors that on a room-by-room basis can control the temperature far more effectively than a centralized thermostat, for example. That's the kind of data processing functionality that at the edge that I think is going to start happening. Is this product available? It's a Kickstarter project. Let's see what happens.
Moving on to RedCap, or also known as reduced capability, Wi-Fi 8 and satellite. Those were topics of interest at CES. Walk us through some of those technologies and kind of your takeaway about those technologies at CES.
Sure. Well, cellular IoT, which is where RedCap primarily applies, has always been under one interesting change model, if you will, which is that after a certain number of years, a next generation version of that cellular system comes along. You had 1G, the analog system way back when Aeris started out. Then you had the 2G and 3G and 4G systems. And now we're at 5G. Well, those things require wireless bandwidth. And so you have to either sunset the older technology and replace it with the next gen technology, or something has to change to allow the next gen technology to come along, which is usually more efficient, faster, can transport more data, etc. Well, over the years, LTE, 4G technology is sort of the predominant thing that's being used in IoT today, and 5G is just starting to be rolled out for a lot of applications that need the capabilities of 5G. Well, what interesting thing that's important about LTE and 5G is to remember that they have these things they call categories of capability. So early phones had a certain throughput capacity, and they were category 1, 2, and 3, LTE category 1, 2, and 3 phones. And they went up all the way to my current smartphone, for example, which is called a category 18 a smartphone, which can transmit many hundreds of megabits per second, megabits per second. Well, the problem is that when you're looking at hundreds of megabits per second, there's generally way overkill for any kind of IoT application, most of them, not all. And so the reduced capabilities of category 1, 2, and 3, and indeed some of the lower level functionality in category M, as it's called in LTE, are capabilities that have been used by all the IoT manufacturers. Well, LTE and 5G cannot technically coexist in the same spectrums, the same wireless bands. So what happens is that you have to replace these devices with things that are 5G compatible. But 5G takes a lot of power. So if you have a battery-operated device, you may have a significant problem with having to either recharge a product or, electrically wired in. So what was developed was something called reduced capability or reduced capacity, RedCap as a short acronym for it, in 5G, so it could coexist with the higher performance requirements of smartphones, but yet you don't not take advantage of all of the high-speed capability, but give you the ability to reduce your battery consumption, reduce the data rates because you don't need it for a given application. If you've got a home sensor or you've got a burglar alarm system, you don't need to transmit tens of megabits per second. You can, as long as you get the data through, unless you're doing a video feed, I suppose. But the point is that the reduced capability in 5G was created as a new standard. So RedCap radios, RedCap chipsets, RedCap modules have just become available in the past year or so, and they're still being announced. In fact, at CES, some of the radio manufacturers came out with RedCap modules. So that's sort of the next gen thing that will replace the low-end 2G, 3G IoT devices, as well as the low-end LTE category M, category 1, all the way up to category 3 devices, so that the carriers, the people who are operating the cellular networks, can take those systems off the air and let 5G dominate, because 5G higher speeds and 5G RedCap can coexist together. So that's the basic push. Now, when you look at Wi-Fi 8, that's sort of the in-home or in-business kind of changes that have been occurring steadily over the years. Most consumer products today are still only Wi-Fi 5 or 6, as they call it, or Wi-Fi 7 is starting to appear right now, which gives you better throughput inside your house. The problem, and this is something that we all need to keep in mind, is that if you have a fantastic high-speed Wi-Fi system at your house, if your internet performance doesn't keep up with that, then you're not going to get the advantages that make sense unless you're doing a lot of things in your house. Now, for example, I'm a little bit of a technical geek, so I have a home server. Mm-hmm. I have a very high-performance system at home that I store data on, for whether it's for music purposes or I do backups from the various laptops in my house. I want a high-speed network. So my Wi-Fi system is actually a Wi-Fi 6 system. I haven't gone to 7 or 8 yet, because 8 is still in the drawing boards, I would say. Chips are coming out. MediaTek announced their Wi-Fi 8 system just recently at CES. And so you're starting to see people get into that. You're starting to see a little bit of expensive products out there. A Wi-Fi 7 router is still in the $200 or $300 range today, which is beyond the necessary cost, price, performance kind of thing for most home users, but it's going to come down in price, and Wi-Fi 8 just expands that further. The reason you want to do something like this is because you may have a home server. It's actually kind of funny. I hadn't even thought about this, but at my house alone, I have about 25 connected products. Not because I'm part of Aeris in the IoT world. It's just things work the way they work. My garage door is connected. If my son calls me and says, "Oops, I forgot to leave I left the garage door open at home," and he's driven 5 or 10 miles away, I can still remotely close it. Whether I'm sitting upstairs in my home office or I'm at work, I can close it remotely. My fridge tells me if the door's been left open. Powerful. Because we've lost food when somebody left the door open and nobody heard the alarm on the fridge. Things like that. When you have 25 different systems in the house, you need a higher speed Wi-Fi system just to be able to take that into account. And it's kind of interesting. In one of our rooms, we have, and I'm going a little personal here, but what the hey, we've got a cable television set up. And in one of the other bedrooms, I don't have a cable jack. So how do I connect? It's a Wi-Fi box. It connects into the system. Now, if you're doing 4K video, you need a high-performance Wi-Fi system. Those are the kind of things that 6, 7, and 8 are targeted towards, and the chipsets that are coming out for Wi-Fi 8 will be helping those. Now, those are not technically IoT, perhaps, but they're smart devices, right? It's part of, one could lump them together, I suppose, in that sense. Satellite, another futuristic approach that is necessary for remote devices. I mean, cellular is great in the vast majority of where humans are deploying IoT devices. Satellite is not needed. Your cellular system is good enough. On the other hand, you may have situations where a product that is in motion ends up outside cellular coverage and needs some kind of a backhaul for whatever reason. Like we have a customer who does fleet operations for their trucking industry in northern Canada. Well, you don't have cellular up there because you don't need the highways in particular. You might get to a city in northern Canada that has cellular coverage, but the highways may or may not be covered. So would a satellite-based system make sense? Absolutely. So they've already deployed a hybrid system where you have a cellular radio when it's in the range of a cellular system, or it uses satellite when it's not. If you're out in the middle of the ocean, of course, satellite is the only way to go. So if you're doing container tracking on a ship and you're trying to transmit that data, satellite's the only way to go. So those systems are coming along. The only issue with satellite is that whether you have what's called a low Earth orbit, LEO, or a geosynchronous orbit system, you have different performance capabilities and different requirements, and it can get expensive if you're not careful. But LEOs have come down in price quite dramatically, and so the radios and the performance of those systems meets the needs of many IoT systems which can afford to pay for that, because if you want to transmit in an area where you don't have cellular, satellite is a logical choice. Now, would I ever do a pure application that ran only on satellite? Well, that would be kind of unusual because most IoT applications are in cellular coverage. So you can sort of do a hybrid solution. And now you're starting to see these hybrid solutions that are driven by the standards. There's something called NTN, the non-terrestrial network wireless frequencies. In fact, modern iPhones and smartphones from Apple and Samsung and other people have the capability of communicating with satellites. And so you're seeing these agreements, for example, between the major carriers and satellite operators to provide capability for your phone when you're out in the middle of nowhere where you may not have a cell tower nearby within a few miles, but you can reach the satellite. Very powerful concept, and I think IoT is going to take advantage of that as long as the price performance justifies.
Well, that's a good segue to my next question. I'm just thinking from the enterprise perspective, how do these options change the economics of deploying IoT at scale?
Exactly right. I think that the low power radio alliance and the the chipsets that are designed for using batteries rather than transmitting with an electrical system where the batteries can last a few years, small amounts of data. If you have a garbage pickup system that doesn't need to send megabits of data, you only need a small amount of data, then you can use one of these second generation low power radio technologies for transmitting. So LoRa, LoRa, low power radio alliance technology, combined with potentially satellite when it's in the middle of nowhere. We were once working with a utility company that had their own mesh network inside big cities. They were using cellular outside the location of the mesh network because it was urban environments. And then they would go into remote areas like ski resorts where they needed to be able to do transmissions, and sending a person out to do an electrical utility meter read was just not cost effective, or a house that's in the middle of nowhere. Satellite makes a lot of sense. So hybrid solutions make a lot of sense. And so a customer who's deploying an IoT solution for doing monitoring or control functions may choose to have more than one data transport. And that's when, all of the issues of single pane of glass monitoring of your functionality come into play. This is things that we've done effectively for cellular. And we've, had people come in and ask us for doing hybrid satellite. We don't do satellite today, but I think it's a natural follow-on for us to even consider doing in the future.
All righty. That was a mouthful. That was a great
technical geekiness. I was great, but that's the way it is.
Yes. I appreciate all the details. So this is the final question, and probably the hardest question, because now I want you to aggregate kind of all your thoughts from CES, and I want you to answer this question. What is the common thread that you took away from CES 2026?
Very good question. I think what it is that CES is back. That's the big message. The past 5 or 6 years, you had a sort of a dearth of product and people who were exhibiting at CES because of COVID and travel and all that kind of stuff. But I think CES is back. That's sort of the main underlying theme. And then the consumers are benefiting from all of the electronics that are being developed and designed, productized, and sold. Now, some of this stuff is incredibly over the top. I mean, I'll phrase it that way. How many people need a 130-inch television, right? That was one of the things that was being displayed. You're not going to have room in your house to display that. But it exhibits technology, where it's going, and what the fallout will be when you take that 130-inch technology and reduce it down in size to maybe a 65-inch television that people have in their house. It gives you a precursor. So my takeaway on CES was, first, it's back, right? I mean, the electronics and the industry is back showing product that can benefit people. And then number two, those high-end displays of technology capability allows people to see what's coming down the pike. That's the big thing. And CES, by the way, is open to the public. I mean, people can go in there and see what's happening. It's almost 150,000 attendees this year, which is one of the larger ones that I recall that has taken place. It's wonderful. And at the same time, tough to wander around looking at everything. I mean, you get a smattering of what's happening out there. It's impossible to see all of the products and all of the people who are on display.
Well, thank you so much, Z. Love having you on the podcast.
Thanks.
So please come back again. And thanks to you, our listeners, for tuning in again for the first episode of the new year. If you have feedback about today's podcast or questions for the Aeris team, please contact us at podcast@aeris.net or leave a comment below. We would love to hear from you. And don't miss our next episode. Episode 11 is all about the fast path to IoT monetization. Until next time, I'm Susanna Song, and this is IoT Real Talk. From all of us at Aeris, thank you for listening to IoT Real Talk. We hope you'll join us again for more real stories from real practitioners shaping the future of IoT. Tune in on Apple Podcasts, Spotify, or YouTube, or visit aeris.com/IoT podcast.